So let's understand that multi-threading behavior. What is that multi-threading behavior? What's the main advantage of multi-threading, friends? What's the main advantage of multi-threads? What is the advantage? I have said that if you are using multi-threads in a proper way, we are going to have a very good application performance. Meaning is what? Execution time will be less, that is execution speed you are increasing. What is that? Performance will be improved. Okay, what is the disadvantage? Disadvantage, if you use the concept not properly, if you are using concept in irregular or in what we call that in undefined fashion, then the application performance will be degrading. Meaning is performance will be decreasing. Okay, performance is going to decrease. Okay, now I am going to show this one. Okay, now think that to prove this multi-threading will improve our application performance. Okay, we are going to write one code, that simple code. First let us listen that requirement. Okay, observe what is that requirement is. Print the natural numbers. Okay, print the natural numbers from 1 to 45 by using 1 second. That is, you have to make your application to print 1 and you have to make your application to stop or resume for 1 second by using 1 second as a resume. That is, for each and every 1 second you have to print what? Natural numbers from 1 to 45 for 1 second. That is, you have to print a single natural number. Observe here, 1 2 3 4 5 6 7 8 9 10, right? You have to print 1, okay, for 1 second. After 1 second you have to print 2, after 1 second 3, after 1 second 4. That is, from 1 to 45 for each and every second. That is, one digit for each and every second. Okay, observe here, print the natural numbers from 1 to 45 digit by digit. Okay, digit by digit by digit for every 1 second. Okay, for every 1 second you have to print natural numbers from 1 to 45. Getting? From 1 to 45 digit by digit for every 1 second. Okay, for 1 second. Getting? Here, observe, after printing, you have to store that, or else let it be we are printing. Okay, let it be. I'll do one small thing here. Okay, observe, digit by digit for every 1 second. Okay, now whenever it is printing, store that natural numbers in one data structure. Okay, you are printing digit by digit for every 1 second and store this every digit in array. Okay, every digit in array, and after printing all these numbers, print that data structure value. Observe here, have printed 1 and after 1 second printed 2, after 1 second printed 3, after 1 second printed 4, after 1 second printed 5. Observe here, when I am printing, that time itself I want to store all these data, the data within the array. Okay, 2 3 4 like that till 45. Getting? Print the natural numbers from 1 to 45 digit by digit and store them in a data structure and print them at final. Okay, and digit by digit and store them in a data structure called as array. Getting? Called as array, and print this array. Getting? Print this array. Getting? And print this array or access that array. Observe here, what's that? Print the natural numbers from 1 to 45. So 1 to 45, I'm going to print these numbers. For each and every single digit printing, there should be, displaying, there should be 1 second. 1 second. What is that? Delay. That is, for each and 1 second, I am going to print only 1 digit. Okay. Now, after that, and store them in a data structure called as array, and print that array finally. Getting? And print this array finally. Getting? And print this array after storing, right? First this one, and you have to store them in the array. Getting? You have to store them in the array. Later finally display all these values. Getting? Why we have to display? Why we have to store? Of course, it's a type of activity. You might be getting one doubt. Why I have to print? Why I have to store? And why I have to retrieve? Think that this is the simple scenario to tell multi-threading is going to improve our performance if I use this one in the proper way. Okay, if I use this one in the proper way. Now let's see the coding part for that one. Okay, first let me take the single thread. Okay, observe here, I am going to take only single thread. Okay, by using single thread I am going to develop this application. Okay, now we have seen earlier how to create the thread, all of these things. Okay, we have seen how to create thread by using, that is, by extends thread class. At our earlier session we have seen that one. I hope you are having knowledge in that one. Okay, now take one class called best. Getting? Take one class called best. Okay, what is a thread? Thread is a flow of execution or a lightweight process. Lightweight means occupying less memory. Other one is what? Lightweight process occupying less memory. Getting? Less memory. Other one is what? Stream of flow of execution. Getting? Flow of execution. Right? Now flow of execution means thread. Thread means flow of execution. Okay, flow of execution means thread. Thread means flow of execution. Okay, now observe, I am going to take one method within this class called best. What is that method? Public static void main method. Okay, public static void main method. What is our requirement? Print the natural numbers from 1 to 45 digit by digit and store those values in data structure called array. Getting? And print this array finally. Getting? And we have to print that array finally. That is what our requirement, right? Now observe here. Okay, now let me create one array. Okay, let it be, let me take one for loop. Okay, and take one variable int I equals to 1, local variable to for loop, local variable to for loop. Okay, now I is less than equals to 45. Observe here, till 45, right? From 1 to 45. Okay, from 1 to 45. Now let it be I plus plus. Observe this part. Now what I am going to do, I am going to print them. I am going to print 1 to 45 for digit by digit for every 1 second. This is our restriction. How we are going to do that? Observe. How we are going to do that one? Observe. Now SOP of let it be anil I. Okay, anil I. If you observe this code perfectly, okay, end of main method and end of class best. Okay, this is main method, this is for loop. Okay, now observe this part. This code is going to execute by JVM. Now observe here, there is a flow from main method starting scope to main method ending scope. Observe here, there is a flow of execution is there, and this flow of execution is called as thread, and in vice versa, thread is called as flow of execution or lightweight process. Can we see the thread? No, we cannot see the thread, but we can feel that through some debug statements. Okay, now if I compile this code, okay, if I compile this code and if I run this piece of code, let it be the code name as what? Best.java, source code name. How to compile this one? Java C space best.java. And how to run? Java space main method corresponding class. What happens now? What happens now? Observe here, what happens now? Observe, I am going to print. Observe this one properly. Okay, just a minute to compile and execute this piece of code. Observe, friends. Okay, now here take one class. Okay, let it be, let me delete. What is that? Take one class called best and take one public static void main method. Okay, string args. Okay, now observe here what I am doing here. I have taken one variable, local variable I equals to 1, I is less than equals to 45, I plus plus. Observe properly, friends. Okay, system.out.println ANILI. Okay, now observe here we are having what? A flow of execution. That flow of execution is called as a thread. Getting? Now what is that thread name? It is main thread. Okay, of course, even don't bother about this name. Okay, but feel that there is a thread. Okay, there is one flow of execution. What is our requirement? Print the natural numbers from 1 to 45. Let us achieve till here. Okay, we'll go for that one later. Okay, we go for that later. Okay, now observe, if I do compile and execute, I'll get what? Anil 1, Anil 2, Anil 3 till 45. Observe here, do we get any delay for each and every 1 second? That is digit by digit for every 1 second. No, we are not going to get output in that fashion. Observe here. Now let me compile this one. Java C, what is the source code name? Java C best.java. Observe, best.java compiled successfully. Now main method name best. Okay, observe here, you are having from 1 to 45. Observe here, I am going to execute once again. Do you have any digit printing for 1 second? That is for each and every 1 second. Are we printing this 1 2 3 4 like that? No, we are not at all printing. Are we printing, guys? No, we are not at all printing. Now observe here, to make our application or print only one digit for 1 second, from 1 to 45 numbers, one digit for 1 second, from 1 to 45 natural numbers. Getting? Observe here. Within the class called thread, okay, we are having one method called as sleep method, okay, which is a final void, okay, having argument as what? Long milliseconds, okay. Observe here, final void sleep milliseconds. Observe here, think that you are having one class A, okay, you are having one class A. Within this class, can I have public final void static? Can I have public static void m1? Can I have the method like this or not? Yes, we can. And of course, this sleep method is a static method, okay. It is what? A static method. Observe. Can I have static public final void m1 method? Yes, you can. No issues, okay. Then think that you are having some implementations here, okay. Some implementations. Now observe this part. Observe this part. It's having some implementation as what? Telling hi to us. Now in the same fashion, we are having in the thread class one final static method, which is also a native method. Prototype is not important to us. Now just implementation is important to us. Now this method is having logic. This method is having logic to make the thread or put the thread, okay, make or put the thread, okay. It is having logic to put the thread in sleep mode for specified milliseconds, okay. What it will do? Logic to put the thread in sleep mode for specified milliseconds, okay, for the specified milliseconds, okay. Logic to put the thread, okay, logic to put the thread which is executing, okay, which is executing this method, okay, which is executing this method. Observe here, logic to put the thread which is executing this method, okay, which is executing this method in sleep mode for specified milliseconds. This is milliseconds, okay. Thread which is executing this method, okay, will sleep, okay, that will be put in sleep mode for specified milliseconds. This is the static method within our class called thread, okay, and it's having the logic as this one, okay. Now observe. Now think that I'm having one more class called class A1, okay. Now this is what? Static method. I want to print hi, okay, I want to print hi within this main method of class A1. How to call this method? Class name dot m1. What will be the output? Hi from, okay, let it be hi from A1, okay, hi from A1, okay, hi from A1, okay. This will be the output, right? Yes. What will be the output? Hi from A1 will be the output. Using class name to call what? Method, okay. Using class name to call what? A method. Observe here. Observe here, I'm going to use a little exception handling concept. That's simple. You are not recommended to have much knowledge in this one. Whatever I'm going to put here in front of you, more than enough to understand this requirement. Okay, now think that this method throws a checked exception. Getting it throws what? An exception. Okay, let it be as what? Exception. Okay, what is the meaning of throws? What is the meaning of throws means? What is the meaning of throws means? Delegating or else delegating or transferring exception handling work to the caller. Observe here, what is this throws keyword? Exact behavior. Okay, throws keyword exact behavior is transferring exception handling. Observe here, transferring. Okay, transferring the exception handling duty or responsibility to the caller. Okay, to the caller. Now main method is what? Caller of M1. This is the callee. Strictly this is what? Callee. This is what? Caller. Okay, main method is what? Caller here. Think that it throws an exception. Meaning is what? What is strictly exception? What is? Observe, instead of exception, let me go with interrupted exception. Okay, let me go with interrupted exception. This is also one of the class name. Observe here, what is exception? Strictly. Getting what is exception? Strictly. Okay, simple. Observe here, exception. Okay, don't get confused with exception and with the class name called exception. Okay, this is a class and this is the terminology. What is exception? Okay, technical definition I am going to give now. Exception means simple, it is an undefined act or work. That's it. This is an undefined act or work. Getting? Now if you do write a code, okay, if you do write a code which is representing, okay, which is representing an undefined work or act, then there will be exception. Okay, that is, there will be what? Abnormal termination. I mean, from that point onwards, observe here, you are having some lines of code. Okay, you are having some lines of code. Now at this line you have written one undefined activity code. Okay, undefined activity code. Getting? Undefined activity code to execute by JVM. Okay, observe here, think that it is your public static void main method. Okay, now who will execute this method? Our JVM. Through what? One flow of execution. Okay, there will be one flow of execution. Flow of execution means a thread. Okay, now observe here, you are having one undefined activity code. If such type of activity codes are existing, means JVM will not execute the remaining part of the code. Okay, that is called as abnormal termination. I am not terminating this one normally, abnormally in the middle I am just terminating. I don't want to execute all of these things. I have one undefined activity code. I cannot do that work. Please let me know that undefined activity. Then I will do execution of this part. Like that JVM will convey message to us. Okay, what is here? Observe. What is exception? It is undefined act or work. Getting? It is an undefined act or work done by or doing by JVM. Okay, doing by JVM. Observe here. Here I have written one undefined activity code. Who will execute this code? Our JVM. If JVM is executing this code, means it will perform undefined activity, right? Yes, doing by JVM. Undefined activity doing by JVM, right? Yes. Now from this statement onwards, no statement will be executing. Getting? That is called as abnormal termination. Getting? Abnormal termination. Okay, this is what our exception. Okay, now observe here. Observe here. Now think that you are having int I equals to 0. Okay, int I equals to 0, int a equals to 9. Okay, if a is not equals to, okay, no issues. If a is greater than 99, okay, now observe here, I have written undefined code, friends. Okay, undefined code, undefined activity code. Getting? Undefined activity code. Let me know one thing, this is within the public static void main. Does this code executes? Please observe logically. Does this code executes? Now what is the value of a? 9. 9 is greater than 99? No, 9 is not greater than 99. 9 is less than 99. Now it will not execute this undefined activity code. Okay, who? Our JVM will not execute this undefined code. It will come out of this if block. It will execute this end scope properly. Now what it is? What it is? Abnormal termination or normal termination. Observe. If it is executing undefined activity code, then rest of the code will not execute. That states abnormal termination if it executes undefined activity code. Now does our JVM execute undefined code here? No, it's not executing, right? Yes, it is not at all executing that undefined code. Now it is what? Normal termination. Okay, this is what? Normal termination. Okay, now observe. Observe here. Okay, now think that I have one dangerous undefined code. Okay, think that I have one dangerous undefined code in my method. Okay, undefined code in my method because of some logic. Okay, what is that? Int a equals to 9. A is greater than 99. Now here I am having that undefined activity code. Getting? Observe, friends, observe what we are discussing. We are about to discuss multi-threading performance, that is how multi-threads are going to improve our application performance. Number 1, what are those advantages? Simple thing, it improves performance of our application. Disadvantage, decrease the performance of our application. And now what is a thread? It's a flow of execution. What is flow of execution? It's a thread, vice versa. And it's a lightweight process, meaning is occupies less memory for execution of our application. Now it also can be spelled as stream of flow of execution. Okay, it's a stream, it is a stream of flow of execution. Okay, now we are having one requirement. What is that? Print natural numbers from 1 to 45 digit by digit for every 1 second. Digit by digit for every 1 second. And store them in a data structure called array, and finally print them. That is print array containing element. This is what our requirement. So first I am developing that application without using what? Multi-threading. Observe here. Here you are having single flow. So we are going to develop this application by using single flow and also by using multiple flow of executions. If I put multiple flow of executions, that is multi-thread. Okay, that is multi-thread. Here this code will be executing from top to bottom. That is the flow. What is the flow means? I can go in zigzag way also, but here what is the flow means? Top to bottom. You are having one execution flow, that is called as a thread. Here you are having single thread. Okay, now observe. I have taken one for loop with local variable 1 and it is less than equals to 45. I plus incremental section. I printed here. What is happening here? I printed 1 to 45, but I didn't achieve digit by digit for every 1 second. Okay, for every 1 second. To achieve this one, okay, we are discussing this one. What is that? Observe. Within our thread class, we have one final static method which is public. Getting? Which is public. Okay, we are having one method called as sleep method, having argument as long milliseconds. Within this method, we are having the logic to make the thread or put the thread which is executing this method in sleep mode for specified milliseconds. This argument for the specified milliseconds. Okay, now for the specified milliseconds, how that static final method is available in the same fashion, I can take one more method. Observe here how this method is available in our general A class. In the same fashion, this class is also having, that is predefined class, one static method called as sleep method. Okay, now come here. Now forget about this throws, will come. Okay, now it is having one implementation as what? SOP high from A1, which is static method. How to call this? Static method M1 of okay, this is what? A, right? Let it be A. How to call this static method M1 of class A from this class A dot M1. This is being as caller, this is being as callee. Leave it all of those things. Now